Lenses are the magnifying glasses. These are of two types, namely concave lens and convex lens. Lenses are transparent and light can easily pass through them. Convex lenses are thicker in the middle than at the edges. The images formed by the convex lens are not captured on the screen if the object is too close. So, these are virtual images. When the object is kept far from the lens, the image can be easily captured and it is said to be a real image. Terms related to lenses. Optic center O. It is the geometric center of the lens. Center of curvature 2F. It is the center of the imaginary spherical surface of a lens. Principal axis. It is the imaginary line passing through the optic center and center of curvature. Principal focus or focal point F. When a parallel beam of light is incident on a convex lens after refraction, converge at a point called principal focus. Or, when a parallel beam of light is incident on a concave lens after refraction, it appears to diverge from a point called principal focus. Focal length. It is the distance between the optic center and the focal point. Power of a lens, P. The reciprocal of focal length of a lens is called power of a lens. The SI unit is diopter. Lens formula. Lens formula. It can be given by 1 by F equals to 1 by V minus 1 by U. Magnification can be given by M equals to H dash by H, which equals to V by U. In applying lens formula and magnification, we have to follow some sign conventions. Object must be taken on the left side of the lens. Distances are measured from optic center. Optic center is taken as the origin. While measuring distances and heights, we have to follow Cartesian sign conventions. F and P are positive for convex lens. F and P are negative for concave lens. U is negative. Note, while measuring the focal length of a lens, we have to consider the focal point through which refracted ray passes. Images formed by convex lens. If the position of object is at infinity, the position of the image is at focus f2. The relative size of the image is highly diminished and point-sized. Nature of the image is real and inverted. If the position of the object is beyond 2f1, the position of the image is between f2 and 2f2. The relative size of the image is diminished and the nature of the image is real and inverted. If the position of an object is at 2f1, the position of the image is at 2f2. Relative size of the image is same size and the nature of the image is real and inverted. If the position of an object is between f1 and 2f1, the image formed is beyond 2f2. The relative size of the image is enlarged and the nature of the image is real and inverted. If the position of the object is at focus f1, the position of the image will be at infinity. The relative size of the image is infinitely large or highly enlarged, and the nature of image is real and inverted. If the position of the object is between focus f1 and the optical center O, the position of the image will be on the same side of the lens as the object. The relative size of the image is enlarged and the nature of image is virtual and erect. Images formed by concave lens. If the position of the object is at infinity, the position of the image will be at focus f1 and the relative size of the image is highly diminished and point-sized. The nature of the image is virtual and erect. If the position of the object is between infinity and the optical center O of the lens, the position of the image will be between focus f1 and the optical center O. Relative size of the image is diminished and the nature of the image is virtual and erect.